morning, children. In today's class, we are going to learn how to identify the type of conic. Given a second degree equation, say ax square plus bxy plus cy square plus dx plus ey plus f is equal to 0. Let us shortlist the conditions. A few hints will help us to easily identify whether the given curve is a circle, parabola, ellipse or hyperbola. How to do it? Now already we learned the double cone which is intersected by a plane gives rise to the various shapes. The plane cuts horizontally, it is a circle. The plane cuts inclined, it is an ellipse. The plane cuts only part of it inclined this side. So that is a parabola. If the plane is cutting both the cones up and down, we get a hyperbola. And that is why we say these shapes are derived from a cone, hence called conic. Now, looking at an equation, even before drawing or sketching, how to identify the type of it? xy term is 0, that is b equals to 0, and x square and y square have same coefficient, that is a equals to c. Immediately we can declare it is a circle. So a circle equation, as we did in very first exercise, we recalled there is no xy term and a and c, that is x square and y square, have same coefficient. The second case, now also there is no xy term, but either a or c, any one term is 0. That is, in an equation, either x square should come or y square should come, and this I call a parabola. Not both the terms, x square term or y square term, should come in the equation. Also, xy term should not come, that is b equals to 0. This gives rise to a parabola. The third condition, a and c both are present. They are not equal. If they are equal, it may become a circle. If they are not equal, now both may have same symbol. This is plus, this is also plus. Or this is minus, this is also minus. So same signs tells me it is ellipse. And if they are of different signs, that is x square term positive, y square term negative, or y square term positive, x square term negative, that is the case, we call this gives rise to a hyperbola. So just looking at an equation, try to identify the type of conic. Exercise 5.3, identify the type of conic. 2x square minus y square equals to 7. See, here 2, here the number is 1. So they are not equal and there is minus symbol. So this is a hyperbola. So how do I identify? X square, y square coefficients are different and one is positive, one is negative. So this gives rise to a hyperbola. The second equation, here there is no xy term. Whenever there is no xy term, it may be a circle or parabola. Here, both x square and y square are present, having same coefficient. So, this is a circle. No xy term and x square and y square are having same coefficient, tells me it is a circle. Here again, x square, y square are present with different coefficients and plus symbol. Both are having same symbol. It is an ellipse. If x square and y square are having different coefficients and same symbols, tells me it is an ellipse. Here there is no xy term. So it can be a circle or a parabola, but the same coefficients, x square and y square have same coefficients, tells it is a circle. And now we have an equation in this. Xy term is not there, but x square and y square are having different symbols. X square positive, y square negative, and the coefficients are also different. So this tells me it is an hyperbola. Whenever x square and y square are having different coefficients and different symbols, it is a hyperbola. The sixth problem, here there is no xy term. It may be a circle or a parabola, but there is no x square term. Only y square is present. Either x square or y square is present. This represents a parabola. So parabola tells me out of all the equations, very easy to identify. Only y square will come or only x square will come. So either x square or y square comes. It is a parabola. Parametric form of a conic. Why do we need this parametric form? Generally, we call equation of a parabola y square equals 4ax. For an ellipse, it is x square by a square plus y square by b square equals to 1. And for a hyperbola, it is x square by a square minus y square by b square equals to 1. For a circle, it is x square plus y square equal to a square. In all these equations, I find x and y. Solving equations involving two variables is difficult when I compare to that which is having one variable. So this x and y also we make as one variable. That one variable we call parameter of a curve. How to write it? When I take the very first equation, y square equal to 4ax. Wherever x is coming, put at square. Wherever y is coming, put 2at. See what we get. Y square will be 2at the whole square. That is 4a into x value at square. Here 2 square 4, a square t square. Right hand side also a into a square t square. It is satisfying. So I am writing x and y in terms of a single variable t, which is called as the parameter. So at t we say, and what does the t mean? It is at square comma 2at. Writing x is equal to at square, y is equal to 2at, we call parametric equations. Writing at square comma 2at as a point, I call parametric representation. Both are same only. Here I given point form, whereas here I given equation. Now, is it possible for the remaining three? How to guess the answer? Circle. What is the equation of circle? X square plus y square equal to a square. Recall trigonometric identity, that squaring and adding. Immediately what comes to my mind is cos square theta plus sin square theta equals to 1. Whenever you have square and plus symbol, remember this identity. But right hand side is a square. So multiply by a square. I get a square cos square theta plus a square sin square theta equal to a square. Now compare. Square and square I take. X is equal to a cos theta. Again square and square will go. Y is equal to a sin theta. And this is parametric equations for a circle. So whenever I have plus and squares, let me remember this trigonometric identity. Cos square theta plus sin square theta is equal to 1. Since I need a square in the right, multiply the equation fully throughout by a square. And I compared x is a cos theta, y is a sin theta, which gives rise to the equation. This we call parametric equations for a circle. Suppose I want the point form. I will write a cos theta, comma, a sin theta. The same I can extend to an ellipse by putting b square. So instead of a and a again, put b here and check. See whether you are able to get it. So I am taking a cos theta, b sin theta. Now put this in ellipse equation. Check whether you are able to achieve that answer. What is ellipse equation? X square by a square plus y square by b square equals to 1. So we get, in the place of x, put a cos theta. A square cos square theta plus y is b sin theta, b square sin square theta, which is a square cancel, b square cancel, giving rise to cos square theta plus sin square theta, which is 1, and that is the RHS. So parametric equations for an ellipse. We say x is equal to a cos theta, y is equal to b sin theta, and if I want the point form, I call a cos theta, comma, b sin theta. This we say at theta. This we say at t. How can I guess for a hyperbola? What is hyperbola equation? The same formula like ellipse, but there is minus symbol in the middle. So hyperbola equation has minus. Recall the trigonometric identity, which squaring and subtracting I get 1. It is secant square theta minus tan square theta equal to 1. So I see the minus and squaring, immediately recall this identity. Secant square theta minus tan square theta is equal to 1. Here I have by a square. So you multiply by a square. Here I have by b square. So multiply by b square. Now these two are one and the same. Right hand side is 1. Denominator of the first term a square, second term b square. There is a minus symbol. Compare. X square is a square secant square theta. So what is x? A secant theta. Y square is b square tan square theta. So what is y? It is b tan theta. And this is the parametric representation for a hyperbola. Having known all this, how am I to proceed for a tangent, normal for the given equations? We recall writing the tangent equation for any curve. X square becomes xx1, y square becomes yy1, x as x plus x1 by 2, y as y plus y1 by 2, and constant as it is. Coming back to parabola equation, y square will become yy1, 4a, x will become x plus x1 by 2. As I cancel, this is tangent equation. To go to normal equation, tangent and normal are perpendicular. For any curve, I draw the tangent at a point. If I draw a perpendicular, this perpendicular I call normal, whereas the line touching at one point I call tangent. And remember, tangent and normal are passing through the point x1, y1. Both pass through that point. How to derive the normal equation? Whenever the two equations or the two lines are perpendicular, I use the condition m1, m2 is minus 1. Rewriting this tangent, it is 2ax minus yy1 plus 2ax1 equals to 0. Normal, which is perpendicular to the tangent, put x coefficient to y and y coefficient to x, change the symbol, writing perpendicular equation. X coefficient to y, y coefficient to x, change the symbol, constant also changes. To find k, this normal also passing through x1, y1. So wherever x comes, put x1, and wherever y comes, put y1 equal to k. Put this back in normal equation. Xy1 plus 2ay equals to x1y1 plus 2ay1. So we have derived tangent and normal using the condition at x1, y1 with this technique for tangent, normal being perpendicular line to the tangent. The same idea I can extend for ellipse or hyperbola. Try it on your own. Ellipse equation, we write the tangent using the technique. X square becomes xx1 by a square as it is plus as it is. Y square becomes yy1 by b square equals to 1. For a hyperbola, it is xx1 by a square minus yy1 by b square equals to 1. For a circle, xx1 plus yy1 equals to a square. In all these cases, write the normal using the formula x coefficient will go to y, y coefficient will go to x. Also change the symbol. Tangent positive, normal it would become negative. Find out k substituting the point x1, y1. Now we tabulate all these answers for equations of tangent and normal. And the next case, wherever x1, y1 are coming in these equations, let us put the parametric form and derive the parametric form of tangent also. So as we see the table, let us understand better. Parabola, ellipse, hyperbola, circle. The parametric form, as we had discussed earlier, we have tabulated. And moreover, we must know the parameters t can be any real number from minus infinity to plus infinity. Theta, when I say it is a complete rotation, 0 to 360 degree. One complete cycle we say. So 0 to 2 pi for theta. The same is with circle also. When we come up to hyperbola, tan theta and secant theta are coming. Remember the range from minus pi to plus pi, and whenever tan theta comes, 90 degrees should be eliminated because tan 90 is infinity. So accept the point theta equal to plus or minus pi by 2. Having known the equations of parabola, ellipse and hyperbola in standard form, where here the vertex 0, 0, here the center is 0, 0. So when I know these equations, as we already discussed, it is good to tabulate the results so that learning this will help you understand and apply in exercise problems. Now, any curve, when we say from a point outside the curve, I can draw two tangents. The curve is like this or like this or like this. From a point outside, I can draw two tangents. Remember. But when I come for normal, it differs. For a parabola, we can draw three normals, whereas for ellipse and hyperbola, we can draw four normals from any external point. That is, this is the curve, point is somewhere here. Point is not on the curve. From an external point, we draw two tangents, whereas for parabola, three normals can be drawn, and for ellipse and hyperbola, four normals can be drawn. And we remember a very important condition: when I give you a line y equal to mx plus c. Is that line a tangent to the parabola or ellipse or hyperbola? How to identify? We have the condition C value is a by m. It touches the parabola. C value is root of a square m square plus b square. Whenever square root comes, remember to put plus or minus. If this condition is satisfied, it is a tangent to the ellipse. And same thing we write, instead of plus symbol I put minus b square. It is a tangent to the hyperbola. So we have important problems based on this formula. Parabola C value is a by m. Ellipse C value is plus or minus root of a square m square plus b square. Whereas for hyperbola it is plus or minus root of a square m square minus b square. Now when I am saying it is touching, we should know the point of contact, where they touch. So point of contact also we have derived. Remember the formula for a parabola. It is a by m square 2a by m. For an ellipse, minus a square m by c, b square by c. And for a hyperbola, same thing will come. But whenever in ellipse I have plus symbol, in hyperbola we have minus symbol. The first coordinate no change. The second one, it is plus b square by c for ellipse and it is minus b square c for a hyperbola. Now these things we will understand better when we do the exercise problems. Now, if there is a curve and there are two tangents, what do you say about the two tangents? The two tangents are perpendicular to each other. So whenever you have perpendicular tangents, all such perpendicular tangents will trace something. What is that something? We call directrix in a parabola, director circle in ellipse and hyperbola. And what is the equation of director circle? It is x square plus y square equals to a square plus b square. And the same with minus b square for a hyperbola. What is this director circle? It is the locus of point of intersection of perpendicular tangents. These questions may come under one word. In objective type, they are very important. So tabulate the formula as in the book so that it will be easy for you to refer and apply in the problems.